Today is what? 14, abi? 14. Woman class. Our topic today is light wave. Light wave. Who can tell me any previous knowledge on light? Light. Anybody? What is light? Can somebody tell us? Okay, right. Light is a form of energy. Light is a form of energy that enables us to see things around us. Light is a form of energy that enables us to see things around us. Light wave is an electromagnetic wave that travels in vacuum. Are we there? Characteristics of light. Characteristics of light. 1. It is very fast. In speed. Very fast in speed. What's the speed of light? Anybody? 3.0 8 meters per second, right? What's the meaning of this? This means that light can travel 300 million meters in 1 second. Oh, you don't get? I mean, let's write it in full. This is full value. This is 3 times 10 to the power 8 meter per second. That means in 1 second, light can travel through a distance of what? 300 million meters in 1 second. That's the meaning. So it is very fast, and this speed is applicable in vacuum. So light is fastest when it travels in vacuum, in empty space. That is one of the characteristics of light. Another characteristic of light is that it enables us to see things around us. It enables us to see things and identify colors. It enables us to see things and identify color. If there is no light, you cannot identify color. Why? Because the color object gives is as a result of reflection of light on it. Another property of light, characteristics of light is that it can be reflected. Light can be reflected, refracted. Light can be polarized, and it can be interfered. Light can be reflected, refracted, polarized and interfered. These are different properties of light. We still have more of it too. Now, let's take those properties one after the other. Properties of light. Properties of light. Number one, let's pick it from here. Light can be reflected. No, let's take it one after the other. Reflection of light. Two, refraction of light. Polarization of light. So what is reflection now? Let's start from reflection. Reflection of light. The first one. Reflection of light. Reflection of light occur when light rays are rebounded from an opaque object. Or obstacles. Look at this. If you have a surface, this is a plane surface. Plane surface. There is something we call the normal ray. Normal ray is a ray of light that is always perpendicular to the surface. Let me make it down. That is always perpendicular to the surface. This ray is called the normal ray. How does reflection happen? When light ray strike the surface, the plane surface like this ray is called the incident ray. What I call it? Incident ray. There will be an angle of incident here. Let me say theta. This is the incident ray. When it strikes the plane surface, a surface that is opaque, that will not allow the light to pass through it. So when the light strikes this surface, it's going to come back in that same direction like this. This is the incident ray, and this one that comes back is called the what? Reflected ray. Reflected ray. It will also go back at an angle of theta r. What happened there? Reflection of light has happened. It occurs when light rays are rebounded from the opaque object. This is an opaque object. The light rays strike it and it rebounds. So what is now the principle we want to bring out from here? The principle says that the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. So, law of reflection now. Law of reflection of light. The law states that the incident ray the normal ray and the reflected ray all lies on the same plane. That law is called law of reflection of light. The law says that the incident ray, the normal ray, and the reflected ray all lies on the same plane. I want us to do little calculation. That's the first law. The second law tells us that, I said that earlier, that the angle of incidence, is equal to what, class? Yes, to the angle of reflected or reflection. The angle of incidence is equal to the angle of reflection. That is theta I equals to theta R. Keep note of that. Now there is still another ray that I have not mentioned. I mentioned 3 rays here. Who can tell me the 3 rays of light that I've mentioned here? Incident ray, the normal ray, and the reflected ray. So another ray we're supposed to have now is, let me clean it. If this ray is to go on a straight line, let's look at it. If this ray is supposed to go on a straight line, so that means the continuation is supposed to be like this. Supposed to be like this. Don't mind my straight line up. This ray now is called deviated ray. What I call it? Deviated ray. Yes, deviated ray. So we are going to check the angle of deviation. From here now, if this is supposed to go, it's supposed to keep going on a straight line like this, but instead it's deviated like this. At what angle does it deviate? That's what we want. Angle of deviation here, D. So what is going to be D? If you have to check, everything is on a straight line now. If you look at this, sum of angle on a straight line, what's that going to be? Theta I plus theta R plus D will be equals to what? 180, which is sum of angle on a straight line, 180 degree. So from here, the subject, I have D to be equals to 180 degree minus theta I plus theta R. Do you get that? So we can use that one to get the what? Angle of deviation. And you agree with me that theta I is equals to theta R. If they are equal, then I can replace one of it like theta I plus theta I. Am I correct? Because theta I and theta R, they are the same. So this will become what? 2. So D is still the same thing as 180 degree minus what? 2 theta I. This will tell me the angle of deviation. Now, basically, the objects that reflect light are called mirror. They are called what? Mirror. Objects that reflect light are called mirror. So what are mirror now? Anybody who can try? Mirror. I mentioned something about mirror now. I said they are objects that do what? That reflect light. Oh yeah, what are mirror now? That's all. Okay. So, right. Mirror is a plane. Mirror is any object. Any object with smooth and shiny surface that can reflect light. What is mirror? Mirror is any object with smooth and shiny surface that can reflect light. Let's echo that together. Mirror is any object with smooth and shiny surface that can reflect light. Okay, so types of mirror. There is one you have at home that you always check yourself when you are dressing. You call it dressing mirror, Abi? How does it look like? Is it curved? Is it round? Is it zigzag? It's flat, right? Like this. This kind of mirror, they are called plane mirror. They are called what? That's the first type of mirror. Plane mirror. Plane mirror. The second type of mirror we have, they are curved. Curved mirror. Curved mirror. The plane mirror and the curved mirror. This curved mirror, we also have their types too. Like we have the concave, we have the convex, basically these two. We have other type of mirror that combine the two together. Plane mirror, let me talk about plane mirror now. Plane mirror, you can ask question now. Plane mirror. What are plane mirror? Plane mirror. Anybody? Before I write. Plane mirror. When you stand in front of that mirror at home, what are those things you usually observe? You observe? You can see yourself. So that means it will form image, right? You that you are standing in front of the mirror, you are the object. The one you are looking inside the mirror is the image. Okay, good. The first property is that it's form image. It's form image of what? Of objects. It's form image of objects in front of it. In front of it. Accepted. Another property. That image that is formed, how does it look like? Your right hand will become your left hand. Thank you. So that is called lateral inversion. Images are laterally inverted. Laterally inverted. Whenever you observe that, you stand in front of your mirror at home, you raise your right hand, and the image in your mirror is also raising right hand. Just run away. Yes, somebody is trying to play prank on you there. If you should raise your right hand in front of mirror, the mirror is supposed to give you what? Left hand. Just like this. If I have mirror like this, this is the plane mirror. If I should put this letter at the front of the plane mirror, letter E, how is it going to be formed? It's going to be formed like this. Like this. How? Like this. Yes, this is lateral inversion. Lateral inversion. Let me give you something to try on that. If I should write this letter, I want somebody that can invert it for me. If this is the mirror, this is the mirror. If I should have who can invert this letter here? Where am I going to start from? From X? From T? Okay. T will be like this. How now? Like this. Normal T. Okay. What of A? Normal A. Okay. What of W? Normal W. What of S? Upside down B. For the A. I should continue. Okay. What of S? Wait, S is like this. And this is S now. S is like this before, Abi. So how will it go now? Okay, good. So it will now go like this now. Okay. So this is how it will be laterally inverted. So this is correct. Let's try one more. Let's say the mirror is here now. This is the mirror. And you have the letter. Pen. How is it going to be formed here? I know it's upside down. How? P is like this. So describe how the inverted form will be. B? Okay. Okay. Out of the E? Facing like this. Normal E? Okay. Out of the N? Upside down. Like this. Like this. Let me write this one very well. Like this. Is it correct? Are you sure? This is correct. So that is lateral inversion. Lateral inversion. If your mirror at home does not invert objects in front of it, go and change that mirror. So another property of plane mirror, I said one, it forms image of the object in front of it. That's obvious. Second one, the image are laterally inverted. Tell me again, what are those things you used to observe when you stand in front of mirror at home? Let me ask one question. If you stand like this in front of a mirror, how will your image be formed? Is your image going to be standing upside down? No, it will stand like this. If you stand upside down, change the mirror. So that is upright. Number 3, the image formed is upright. Is upright, or you use the word erect. The image form is upright, or you use the word erect. Number 4. What did I mean by that? Let me just draw that. If this is the mirror, and you have somebody standing in front of the mirror like this, definitely the image of that person too will be like this. Must also be like that, okay? Not that the person will be standing upside down. Number 4 property of image form in a plane mirror. Observe the distance. When you stand in front of, before the distance, where will your image be formed? Your image, is it going to be on the screen or behind the screen? You don't get that? If you stand in front of a plane mirror, your image is the one inside the mirror, right? That one inside the mirror, is it going to be at the back of the mirror? Like, will it be far from the mirror, or it will be on the screen of the mirror? On the screen of the mirror. That means when you move closer to the mirror, it still remains. When you move far away from the mirror, it still remain like that. How will it be? Look at this now. If this person is standing here, let me show you how it will be on the screen. You are standing like this. It's going to be like this on the screen. Is it like that? It should be here, right? So that means the image is from what? Behind the mirror. Yes. The image is formed behind the mirror. We call that one, the image is real. The image is what? Real. Why? Because real images are formed behind the mirror. Number 5. Let's look at the distance between you and the mirror, and also the distance of your image and the mirror. If you stand in front of the mirror, are you going to be, your image, will it be far from, or your image will be closer to the mirror? Or it will be the same thing? You don't get. This is mirror. I'm standing in front of this mirror. I'm the object. This is the mirror. The image will be formed behind the mirror. The distance of that image formed behind the mirror and the mirror compared to my own distance to the mirror, which one will be closer? Is it that the image form will be closer to the mirror than my own distance, or it will be the same distance? The same distance. So the object distance is the same as the image distance. The object distance is the same as the image distance. If you are standing in front of a plane mirror, any mirror that is called a plane mirror, if you stand in front of it, definitely your image also should be exactly the way you are. The distance between you and the mirror should be equal to the distance between the image form and the mirror. Let me give you one example. If you stand in front of the mirror of a car, what do you usually observe? Mirror, side mirror of a car. Your image will be, the image will be closer. Are you sure? It will be closer or it will be far? No, the image will be far. Why? The reason why, that's not a plane mirror. The mirror of the side mirror of vehicles, they are not plane mirror. They are special mirror. They are specially made for vehicles. Why? So that they can capture objects from a very far distance. It will accommodate more distance than a plane mirror. If you stand in front of a plane mirror, exactly the size of that object will be there. But from the side mirror of a vehicle now, of a car, you can see the complete size of a trailer from it. If it is a plane mirror, that means if the trailer is very close to the car, then definitely you will not see anything from the mirror again. Do you understand? So a plane mirror will always have the same size, the same distance between the object and the mirror. Number 6 now, that's the size. When you stand in front of a plane mirror, your height in front of the mirror should also be the same height as that of the image. Do you get? So image height or let's say size, image height or size is the same as the object's height or size. They will have the same thing. How many properties have we discussed? 6. Let's take the 6 again. Number 1. Again? Yes, if you stand in front of plane mirror, your image will be formed in that mirror. Yes. 2. Images are laterally inverted. That is, if it is right, it will become left. It will be inverted laterally. Yes. Number 3. The image form is upright. Yes, the image form is upright or erect. If you are standing, In the mirror, you will also be standing. You will not be sitting. And you will not be upside down. Number 4.
The image is formed behind the mirror.
The image is formed behind the mirror, and that is real. Real image will be formed, and that is image formed behind the mirror. Number 5.
The object distance is the same as the image distance.
The object distance is the same as the image distance. I've explained that, right? If you are 5 centimeters from the mirror, what will be the distance between your image and the mirror? Then what is the distance between the object and the image? 10 centimeters. Do you get that? So they will have the same distance. Number 6. Image height or size is the same as what? Object height or size. These are properties of objects that will be formed by a plane mirror. Let's check the curved mirror. Can I clean? Okay, this one. Before we move away from that, let me explain a term here. The term is linear magnification. The linear magnification of a plane mirror, the linear magnification of a plane mirror is 1. The linear magnification of a plane mirror is what? Is 1. Why? It's just explaining these numbers. Number 6. It will give you the same size, the image height and the object height. Also explaining this, the distance. Because what do we call linear magnification? Let me just bring it in. Magnification. What is linear magnification? Linear magnification is the ratio of the object distance, image. Ratio of the image distance to the what? To the object distance. Or image height to what? Object height. This is what is called linear magnification. So if they have the same thing, if the image distance and the object distance is the same, by the time you divide them, what will it give us? 1. If the image height and the object height, since it is the same, by the time you divide it, will give you what? 1. So the linear magnification of a plane mirror is 1. Keep note of that. So now let's look at curved mirror. Curved mirror. Curved mirror. I said we have 2 types of curved mirror basically. The concave mirror and the convex mirror. Concave mirror and convex mirror. Concave mirror and convex mirror. Let's start from the first one. Concave mirror. Before the definition, let's consider this diagram. If I have a shape like this, this is the shape of an ellipse. Yes or no? Ellipse. Not eclipse, so ellipse. Eclipse is C. I use double L. Ellipse. Now, if this outside is coated with silver, the outside of this is coated with silver, and the inside is the mirror. The outside is the what? Silver, while the inside is the mirror. If we cut this thing into 2, don't forget, before you can achieve this curve, there must be a center. There must be a what? A center. We call it center of curvature. At which this curve is being drawn. And you know an ellipse. I don't know whether we have further math students here. For you to draw an ellipse, you need two fixed points, right? Two fixed points, the center and the focus. So from that two fixed points, you draw, you achieve this. This is the focus. This point is called the focus. Why this point is called the center of curvature. What did I call F? Focus. And C, center of curvature. So if I should split this mirror like this now, I have this place out of it. So what can you tell me about this mirror? This mirror is a concave mirror. So what I want you to describe for me now is, in the definition, the outside now is coated, while the inside is what? The mirror. So what is a concave mirror? From what you are seeing here, what is a concave mirror? I can't hear you now. You are just murmuring. I said the outside part is coated, while the inner part here is the mirror. So what is a concave mirror? Is a curved mirror. Why the? Write it down. Write it down now. Concave mirror. Concave mirror. A concave mirror is a curved mirror. A concave mirror is a curved mirror in which the inner part is the mirror and the outer part is the silver coated. The inner part is the mirror, while the outer part is the silver coated. Let's go into the description now. This is the silver coat. The part is painted with silver. This is center and this is what? Focus. This line is called the principal axis. This line is called what? Principal axis. And this point here, the point of contact of the curved mirror, the point of contact of that mirror and the principal axis is called the pole. It's called what? Pole. It's called the pole. It's easier for me to work here. Let's say, who can remind me, what is this place called? Yeah, pole. P, pole. What is this middle called? Center of curvature. And the middle part again is called what? The focus. One thing you should know is that the distance between, look up, the distance between, let me write it here. The distance to the center of curvature, the distance from the pole to the center of curvature is called radius. It's called what? Radius. While the distance of the focus to the pole is called focal length. It's called focal length. What is radius, class? What's the meaning of radius? Yes, the distance of the center of curvature from the pole is called radius. Why the distance of the focus from the pole is called focal length. Good. So I'll be using that here. Just the symbol. From here to here is F. This F represents the focal length. While from here to here is the what? R. Let me use small letter R, which represents the radius. Do we get that? Can I continue? Now, we want to look at the properties of image that will be formed by this mirror now. Right. Properties of image formed in a concave mirror. Properties of image formed in a concave mirror. Concave. Properties of image formed in a concave mirror. It is now depending on where you are standing. Okay, where you stand in front of this mirror determine where the image will be formed. Unlike plane mirror, anywhere you stand, the same distance will be between you and the mirror as that of the image form and the mirror. The same distance will be there, but for a concave mirror it's quite different. Let's take it one after the other. I will start from this region. Don't forget, this is the mirror we are facing. So anyone that is standing here, the person is already beyond what? Beyond of curvature, beyond C. Let's go with that now. The first condition are A, when the object is beyond C. When the object is beyond C, where will the image be formed? I'll use this diagram. When the object is beyond C, where will the image be formed? Can I get something flat to draw a line? Like a ruler or something? Somebody should help me get, no, not this one. I mean, longer one, like a wooden ruler. Or a plank, yes. I will use this to explain that. Now, when the object is standing here, let me use this as example. When the object is standing here, please keep note that any ray of light that is formed in this curved mirror, the ray of light that is formed in this curved mirror must pass through the focus. Must pass through the what? The focus. It will pass through the focus like this. Anyone with ruler? Okay. This ray of light, the ray of light from this person is going to go directly to the curved mirror, as in this. The ray comes directly to the curved mirror. Striking on the curved mirror now, where will it pass out? I said it must pass through the what? The focus. To pass through the focus. To go like this. The ray go like this. Okay, thank you, sir. And from here, see the direction of the ray of light too. The ray of light goes like this, in this direction. From here, from the eye level to the mirror, to go in this direction. Then strike the mirror and come in which direction now? In this direction, to go in this direction. Any question on that? This one will be parallel to the what? To the principal axis. The ray of light from the eye level of any object standing in front of the curved mirror, the ray of light will be parallel to the principal axis. Do we get? Parallel to the principal axis onto the curved mirror. When it strikes the curved mirror, it's going to reflect through the way? Through the focus. It will reflect through the focus like this. Do we get that? So this one go like this. And from here too, any ray of light that pass through the, what's it called? The center of curvature, the ray of light will just go straight. It will keep going straight. To go like this. So the image will be formed here. Look at the formation of the image. Why is the image formed here? That is where the two rays of light meet. This one is coming directly like this. The ray goes like this, and this one comes like this. They will meet here. The image will be formed here. Look at this image formed here. This is the object. Don't forget. The object, and here is the image. Compare it to a plane mirror. Compare it to a plane mirror. If this is a plane mirror, the object stands like this, and the image of the object also formed like this. This is behind the mirror. This is the mirror. Okay, this is the object. Why this is the image? The image is formed behind the mirror. But look at this one. Is the image formed behind the mirror? The image is from what? on the screen. The image is formed on the screen. If you are looking at it from the mirror, you'll be looking at that image directly on the screen like this. And this image, let's write the property. 1. What can you tell me from here? After writing this, draw this diagram here, okay? After writing, when the object is formed, when the object is beyond C, then draw this diagram. Because that is where the two rays of light, that's where they are intersecting. The image is now inverted now. The image is upside down. Whenever you are beyond C, like this, whenever you are beyond the center of curvature, by the time the image will be formed, it will obey this. It will go like this, strike this, come. The one passing through the center of curvature. So, and definitely that image will be turned upside down, inverted. So, one of the property of the image form now, what can you tell me from your observation here? What can you tell me? The image is what? Upside down. The image is inverted. The image is inverted. What other thing can you observe from here? It's reduced in size. The image diminished. The image diminished. The image diminished. That is reduced in size. It becomes a smaller size. Is it formed behind the mirror or on the mirror? On the mirror. That means the image is what? The image is virtual. The image is what? Virtual. If the image is real, it will form behind the mirror. But if the it will be on the mirror, okay? The image is virtual. The image is virtual, that is on the screen. The image is virtual. Number 4. Where can you tell me where the position where the object is, the image is formed? Where? Between F and C. But the object is what? Beyond C. The image is now formed where? Between C and F. So image formed between what? C and F. The image is formed between the center and the focus. The image is formed between the center and the focus. Any question on that before we continue? Any question on that before we continue? Yes. On this one alone. Yes. Why is it upside down? Yes. The reason why it's upside down is because the image will be formed to this principal axis. This is the principal axis. The image will be formed to the principal axis. Now let's trace the ray of light. This is the head of this person standing. See the ray from that head now. The ray goes like this and come like this. So if you want to see this head, where will we be seeing the head? The head is here now. Abi? See this head again from here. The ray goes like this, passing through the center of curvature like this. This is the head. So the image will be formed like this. The head of the image will be formed to this direction, then the leg to this direction. So it's inverted. Any question on that? Okay. It's not compulsory we use human being diagram. We can use arrow like this to describe what we want to describe.
Why the image diminish?
It's diminished because as this ray of light, by the time the ray of light intersects, they intersect at a small height compared to the height of the object. The height of the object is a little bit, not a little bit, is higher than that of this. Do you get that now? So that is the reason why it's diminished.
You said image is virtual, but the definition said the real image
Real images
one that can be cut on the screen, like I can see it on screen.
Are you sure? Confirm. Oh. Hope I'm not mixing it up. Somebody should confirm for us. What is real image? What is virtual image? Quickly do that for us. Real image and virtual image, so that we can be on the same page. Real image and virtual image. Confirm that statement. What is real image? Anybody? Behind the screen. Behind the mirror. Okay. Do you confirm that? Okay. No, not from the one I told you now. Check it on. Check.
Okay. And don't forget, as you are saying, this is what I want you to do. Very quickly, those of you who are...
Have you seen it? Let me give you my phone.
Share it with all your friends.
What do you say? No, that's not what I need now. I need on the screen. On the screen. On the screen. No, this is what I want. I want where it will be formed. Which one is behind the mirror? Which one is on the mirror?
Is not from behind the screen, but rather directly on the mirror.
On the mirror, on the screen. The one on the screen is the real.
Yes.
So this one is on the screen. This is the real. Sorry for that. This is real. So change the other form now. The other form is virtual. Yes, the one on the screen is real. On the screen. Why the one behind the screen is virtual? Let's echo that. Real image on the screen. Why the virtual image is behind the screen. Can we continue now? Thank you for that observation. Now, image form between C and F. I have a question for you now. This is my question. Don't check your book, everybody. Close your book. Close your book. We want to look at properties of image form by a concave mirror when the object is standing beyond C. Okay? When the object is standing beyond C. Who can tell me the first thing that will happen to the image? The image is inverted. Yes, is inverted, upside down. Not laterally inverted though. There is a difference between lateral inversion and being totally inverted. Total inversion is the thing will be totally upside down. Okay? The image is inverted. Yes, another one. It will reduce in size, it will diminish. Yes. The image will be formed where? Behind the screen or on the screen? On the screen. The image will be real. It will be formed on the screen. And the last one, it will be formed where? Between C and F. Please keep note of that. Now let's progress. We want to move from here. Look at the stages we have. This is the first stage. The first stage is, let me use it. The first stage is behind C. The second stage is on C. The third stage between C and F. The fourth stage on F. The fifth stage between F and P. And the last stage will be on the pole itself. Or no, you cannot even stand there at infinity. We put infinity as the last one. Okay. What's the second one now? B. Who can tell me B? I've explained that already. Thank you. When the object is on C. When the object is on the center of curvature. When the object is on C, let me underline it. When the object is on C, let's draw the diagram and see how it will go. You can confirm this thing at home by drawing a curve shape like this. When you draw a curve shape, but remember that shape must be elliptical. Okay, here is the silver coated, don't forget. Now the object is standing where? On C. This is how the object will be standing. The object is standing on C like this. Now don't forget our ray of light. How will the ray travel? Class, I said the ray will pass through. When it strikes the curve, it will pass through what? The focus. It will go like this. Since it's heavy, I want us to have a parallel line. I said measure before drawing. I'm just drawing abstractly. So look at this now. The ray comes like this and goes like this. Do you get that? Second ray now. The second ray will come like this, passing through the focus, and it will go out like this. Where will the image be formed now, class? The image will be formed where? Here. What can you tell me about this image? They have the same size, Abi? So let's write 1. The property of image form now. First property. The image is inverted, Abi? Let's first write where it will be formed. Image is formed where? At C. Image formed at C. That's the first thing. Second thing is inverted, right? Image is inverted. The image is inverted. Yes. What other thing can you tell us from this image? They have the same size. Thank you. Image has same size as the object. Same size as the object. What other thing can you tell me? Inverted, the same size. Now, is it real or virtual? The image is real. The image, number 4. The image is real. The image is real. Please keep note of this on the screen. It's on the screen. The image is on the screen. It is real. Who can tell me the next stage now? The first stage, when the object is behind the center of curvature, the image will be formed where? Between C and F. The image will be diminished. The image will be real, and it should be inverted. Thank you. These are the 4 things. Now, when the object is standing at C, the image will have the same size as the object. They will have what again? It will be inverted, it will be real, and it will be formed at C. It will be formed at C. It will be formed at C. Okay. Who can tell me? What's the next position? Between F and C, or C and F, you are still saying the same thing. When the object is between C and F. When the object is between C and F, let's draw the curve and see how it will go. This is my principal axis. Don't mind my cough, but I think it's still better. It's coughing. The cough is coughing. Now, the object will be standing where, class? Between C and F. When the object is standing here, The object is standing like this. Don't forget, the back here is the silver coated and the inside is the mirror. Good. Looking directly at this place, it will go like this. Let me make a rough sketch of it. It's going to go like this. To pass through where, class? To pass through the focus, right?
Yeah.
Okay. When it passes through the focus like this, it will go like this. The second one coming from here will pass through where? Focus 2, right? Don't forget, check the arrow. This strike this and go like this. By the time this is coming, to come like this and go out like this. I did not draw this thing to scale. Where is the image formed now? The image will be formed here. If you trace this image, the image is formed like this. Where is the image from, class? C. The image is formed beyond C. Any question? This will come like this and it will go out like this. So the image will be formed behind C. Let's write it out. Yes, what's the first thing you can tell me? The image is formed where? Image formed beyond C. Image formed behind C or beyond C. 2. The size increase, right? Yes. Image is magnified. The image is magnified. Roman figure 3. Tell me the size first. Okay, we've talked about that. The third one. The image is it real or a virtual? The image is real. Image is real. Do you know when it will be virtual? When the image is formed at the back of this thing, that's when it will be virtual. The image is real. Roman figure 4. The image is inverted. Image is inverted. If you measure this thing very well, see, this diagram on the board is not drawn to scale, okay? If we measure it very well, by the time this thing will be formed, it will not even be closer to C at all. It will be very far. It will be very far at the back. Let me explain something there. This curvature here, this center, look up. This center cannot make this curvature. The curvature will still be found like this if the center is here. They are not always very close like this because it's an ellipse. It's an ellipse, okay? Look at here, look at here. They are always far. So this is how it's supposed to be. So if you draw it in this kind, don't allow the curve to big like this. Let it compress. If it is like this, the image will form at the back here, very far. Do you understand? That's what I mean. It's still the same thing I'm trying to say. Stage what now? Stage 4. Try to memorize because I will ask question on it. Stage 4. Where will the object be standing now? On the focus. On the focus. Okay. Roman figure letter D now. Please stop the noise. When the object is at on F, is on F. F is the what? The focus. When the object is on the focus, how will it be formed? Let me take here to be my center of curvature. Here is the focus. Please don't forget, I said the distance of the radius is twice of the focal length. Don't forget to. Radius is twice of the focal length. Radius is twice of the focal length. We have this. Now, the object will be standing where now? According to this, it should be standing on this. When the object stand here, let's say this is the object. Let's draw the curve. How will the curve go? It will strike.
To strike the mirror.
Strike the mirror.
Yeah.
And pass where?
Pass the focal length.
No. Focus. And pass to the what? Focal length is not a point. It's a distance. The point is focus. So it will pass through this place. And it will go in this direction. So it will go like this. Is it straight? Just manage it like that. It will go like that. Are you good? Why the second one now? The second ray we move in this direction because it must pass through the center of curvature like this. It's getting closer.
I thought both of them was intersecting.
But this one is not intersecting now. They are not meeting. So the image will not be formed. The image is going to be formed at infinity. At what? Infinity. The image will just be blur. You cannot see a particular image. You will observe that the image is there, but the image will be blur. Very blur. So it will not be formed on it. It's just like you are trying to use, for example, you are trying to use your normal phone camera to view down part the universe. Is it possible? You cannot even see any image. It will just be blur. Just blur. That's how it will go, like this. So tell me the property of this image now. No image. No image is formed. That is infinity. The image is undivine. You cannot divine it. Undivine. 2. Or we should say the image is formed at infinity. Formed at infinity, like that. Yes. Is it on the screen or behind the screen? On the screen, right? Image is what? Don't let us use this word, because if I say no image and we are still saying the image is, you will not get it like that. Let's say image is formed at infinity. Let's put it that way to make more sense like that. Image is formed at infinity. Second one now. The image is on the screen, right? The image is real. The image is real. The third one now. Third one. This is the object standing. The image is down. What happened? Inverted. Image is inverted. Image is inverted. And what can you tell me about the size of this image? Why is it that the image is not formed? It just continues like that in a blur form.
It's infinitely magnified.
The image is magnified. Image is magnified. The fifth position now. Any question on this? When the object is between F and P, please stop the noise. When the object is between F and P,
I'm not doing this one. I'm not doing spinning of the mirror.
What is it?
The spinning of the mirror.
Play mirror. We are going to do it. Can we continue? Okay. I said something. I said when the ray will go parallel to the what? To the principal axis, Abi? And it will pass through where? To pass through the focus like this. The ray is going like this. Now look at the second one. The second ray will pass through the what? Center of curvature. The second one passing through the center of curvature like this. So if you look at this ray, so definitely the image will be formed here. The image will be formed here. Only at this position. That is where the image is what now? So let's begin to write. So one, the image is where now? Behind the mirror. That means it is what? It is virtual. Roman figure 2. The image is beyond the pole. Abi? The image is beyond the pole. Magnified. Is it upside down? The image is upright. Come. I will want there. Yes. Now this is the last stage now. The last condition. When the object is at infinity. When the object is at infinity. Object coming from infinity. Let's take the property from when the object is at F. What happens to the image? Reverse is the case. When the object is at F, what happens to the image? The image is formed at infinity. Now when the object is now at infinity, the image will be at F. The image, like the use of telescope and co, they pick object from infinity. Object, when we say object from infinity means something that is very large, that in a normal sense the camera did not supposed to accommodate it. Very large, just like you want to view the sun, for example. Now you want to view the sun, most of the image of the sun that we usually used to see, just part of the sun like this is where they will view, because the object itself is what? A very large object, but you want to view it by something that is very small. The image will come from infinity. Do you get? Not created though. If it is from telescope, it's not created. It is the image that you are seeing, but for it to be formed, it takes a long process. The image is formed where, class? At F. Yes, the image is formed at F. Second thing, opposite of that one, the image is, yes, it's because it's diminished, that's why it is formed. It was very big before, now it's diminished down, that is why it can be formed. Do you get? The image is diminished, the image is diminished. The image is what? Yes, the image is real. No, it's real. Not totally opposite like that. The image is real. And the last one, inverted. Let me see whether you have it in this book. I saw it that time now.
This is going to last. I don't see.
But there is. Okay, converse me. Do you get that? Now, question time. Question time. Are we ready? When you are ready, let me know. Write fast. These things are not parallel to each other. As it is now, image will be formed here. So it's supposed to correct this. It's not correct like this. It's from the curve actually. Dude, this is a rough sketch. You can leave it. Now, I have questions. So, are you ready for my question? Are you ready for my question? General question now. Everybody close your book. Close your book. You can hear me from behind. Close your book. Close it. And your textbook too, close it. It's what? It's paper. If you are using paper too, close the paper. Turn it upside down. Close your book. I want to ask question. Don't write. Stop writing. I want to ask question now. You can hear me now? Simple English. Stop writing. Close this book. I'll be pointing to you at random to answer my question. Don't go. For everybody, that's what I mean. No, I'll be pointing. Whichever way you interpret the English is left to you. Don't go. Question 1. Which one now? I will not play this one. Now the first question. What will be the position of the object when the image form is upright? What is the position of the object if the image form is upright? Who is talking? Who is talking? Signify by raising up your hand. I can hear you. When the object is between the pole and the focus, is that correct? That's correct. That is the only condition where the object, where the image will be. Okay. When the object is on the focus, the image will be formed at dash, at infinity. That's correct. At infinity. Another question. The image is diminished. And it is formed between C and F. Where is the object position? Beyond C. Very good. Beyond C. Okay. At what position will you are copying? At what position will the image height and the object height be the same? You copied now. You copied. At C. I'm not asking for the mirror. I'm talking about concave mirror now. The only position whereby the object height and the image height will be the same is when the object is at where? At C. When the object is at C, the image form will be the same as that of the object. Another question. At what position? What are the two positions whereby the image will be magnified?
When the object is at
who wants to talk now? Somebody is talking here, yes. When the object is between C and F, okay. Okay. Can you try? Ask now fun. When the object is between pole and F, one. Two positions whereby the image form will be magnified. Between C and F and between what? F and P. Between F and P. Yes, that's correct. That is the two positions whereby the image form will be magnified. Okay. Another one. When will the image be erect? Yes. When it is between P and F. When will the image be virtual? When it is between P and F, that is when it's virtual. My last question. Decorum. My last question. Alpha, tell me 4 properties of image that is formed by objects at F. Objects at F. What are the 4 properties of the image formed? The image is real. 1. calm down now, let me hear him. The image is inverted too. Yes, at F. Where would the image be formed? Virtual. After you said real. It's real. Inverted. You said that before now. Decorum now. Who can finish it? Yes. The image will be formed at infinity. And the last one, magnified. The image is magnified. Yes. That's right. Yes. When the other is at infinity. Who is that? Which one? When it was coming, it's going infinity. If it is coming from infinity, what will happen again? It will be inverted in the other way too now. You know, if the object comes from down, it will go like this. That means it's inverted. Anything it come back in that direction, then it is erect. Look at when the object is between F and P now. When the object is between F and P, the object started from here, standing, right? The light ray goes like this and come back like this, still coming back to the erect position. If you check that axis, the principal axis, if the object and the image, if they are on the same plane of the principal axis, then it is erect. But if one is up, the other one is down, it is what? Inverted. That's how we determine it. Do you get that? Good. Okay. One more question. Sorry, it's a slip of tongue. This is the last one now, but not the least again. not the least. I want a lady to answer me now. Who should I call? Let me call you. P. At least you collected my money last week. I have another one for you today, but not now. When the question is conk, I will ask you. Okay. Tell me the 4 properties of image formed when the object is, where should I give her? When the object is between C and F. Listen now, decorum. The image will be formed beyond C. That's correct. Cover that book. That doesn't mean cover it. The image is magnified. Is that correct? Correct. Yes. It is inverted. Correct. It is real. Thank you. That's correct. Okay, now let's move to convex mirror. Or do you have question for me? Before we leave that concave mirror, do you have question for me? No, we are going to the calculation aspect. Don't worry. Let's finish this theory part now. We now enter the calculation. We are going to do calculation on them. Don't worry. Any theory question for me on it? Can we proceed? Okay, good. Now, convex mirror. Oh, yeah, right. Where's my marker? Which one? Inverted. Convex mirror. What is a convex mirror? What is a convex mirror? Check the definition of concave to define convex now. Thank you. Somebody has already said that. She said the inner part is silver coated while the outer part is what? Is the mirror. Yes, that's a convex mirror. I should clap for you. That's a convex mirror. A convex mirror is a mirror It's a curved mirror where the inner part is the coated part and the outer part is the surface. Is the mirror. Yeah, write the definition. Right. Now let's look at properties of image formed in a convex mirror. Properties of image formed in a convex mirror. Open to that diagram. I want to check something. Properties of image formed in a convex mirror. 1. At any position of the object, the image is 1. The image is diminished. The image is diminished. At any position, the image will become smaller. Very sure. Second, the image is erect, upright. At any position is upright. The image is upright. Third, the image is virtual. The image is virtual. So definitely 4 to be formed where now? From where? Since it's virtual. Behind the mirror. At any position. This one, don't stress yourself. At any position, the image is inverted, the image is diminished, erect, and virtual. Do you get that? Confirm from your book there.
This is upright behind the mirror.
Let's draw the diagram. What? What's the same thing? For convex, at any position, yes. To always follow this at any position. Just like plane mirror now. At any position of the plane mirror, you always have the same distance. You always have upright. You always have everything. So let's say here is the silver coated. Class, are we together? Definitely, please look up. My center of curvature, will it be at this side or this side? Look at the way the shape is. Center of curvature will be at this side, Abby. Center of curvature is here. Here is my focus. Are we good? Now the object is now standing here. That's where the object is standing. Are we good? Now how will it go? Any ray of light that strikes the mirror, what will happen? It will come out through the air. The focus, Abby?
Yes, sir.
Okay. But that ray of light must be parallel to this one.
Abby, the image at the front of the mirror, the object,
Is at the front now. This is the mirror.
Okay.
Is it parallel to that surface? The ray will be parallel to this surface, so don't forget. It will come out through where? It will come out like this. Why this one? We directly pass through the where? Center of curvature. The same diagram. Where is the image formed? Point of contact, have you? Look at the height of the image or object. See the object. Now see the what? Image. Is the image upside down? No, it's upright. Let's begin to check. Does it diminish? Yes, very well. It diminish. Is it right? It's upright. Virtual. Behind the mirror. Behind the mirror. This is just repetition. Yeah. You can take any position here, but it is all virtual. They are all virtual. Now let's write this theorem down. I want to give us a short theorem that we'll be using our calculation. Who can tell me the magnification of, are we together? The magnification of a convex mirror, will it be greater than 1 or less than 1? Because it's reducing. Don't forget, magnification is less than 1. Magnification is less than 1. Oh yeah, I want us to write this table now. The first column, right, real is positive, and the second one, new Cartesian. Real is positive, and here, new Cartesian. Yes, stable. The first column under that now. The first row under real is positive. Are we there? Please pay attention now. The first one, real object and real image are at positive distance from the mirror. Yes, under real is positive. Real object and real image. Real object and real image. Let's put the plural form. Real objects and real images. Can you hear me? It's a table. We want to use it. The knowledge of this table will be applied in the calculation we're about to start. It's not property. You can just continue your notes down like this. Just draw a table and continue. Okay, under real is positive. Under real is positive, right? Real images and real objects and images and real images are what? Are at positive distance from the mirror. Are at positive distance from the mirror. Are we there? Under Cartesian, what is it? Under this, right? Real objects and real images are at positive distances to the mirror. That's all. Under the second one, right? Under the new Cartesian, Distance measured to the right of the mirror are positive. Distance measured to the right of the mirror are positive. Distance measured to the right of the mirror are positive. You are not writing. Okay. Distance measured to the right. Distance measured to the right of the mirror are positive. Number 2, virtual images are at negative distance from the mirror. Virtual images are at negative distance from the mirror. Under the real is positive. Virtual images are at negative distance from the mirror. Please, I can't shout to. Just stop the noise there. From the mirror, negative distance from the mirror. Under the second one, we have distance measured to the left of the mirror are negative. Distance measured to the left of the mirror are negative. Distance measured to the left of the mirror are negative. Number 3. Number 3. Focal length of a concave mirror is positive. Focal length of a concave mirror is positive. Focal length of a concave mirror is positive. Under the second part, focal length of a concave mirror is positive. Do you get it now, bro? Do you get it now? Okay, good. Focal length of a concave mirror is positive. Under the second part now, focal length of a concave mirror is negative. In this part, focal length of a concave mirror is negative. On this side, focal length of a concave mirror is negative. The last one now, number 4. Focal length of a convex mirror is negative. Under the real is positive. Under the real is positive. Focal length of a convex mirror is negative. Focal length of a convex mirror is negative. Under the real Cartesian, what will it be? Thank you, it's positive. Under the new Cartesian, it's positive. What do we mean by real is positive and new Cartesian? When you hear the word Cartesian, we are talking about graph. We are talking about what? Graph, yes. Graph. Cartesian is talking about graph. The person who designed graph then is the one that bears this name. His full name is Rendescat. Cartesian plane. That's that for that. But here, real is positive. When we begin to check the direction of this along the plane is what we are looking at. Now, let's take that. The first one again. Go back to the notes. What's the first thing I mentioned? Now, real object and real image. What do we use to represent objects? What do we use to represent object? When you see the word, the letter U, okay, U represents object distance. Represents what? Object distance. And V represents image distance. Are we together? U represents what? Object distance, while V represents image distance. F represents focal length. F represents focal length. R represents what? Radius. All these things, they are all distance. Object distance is the distance of the object to the mirror. Image distance is the distance of the image to the mirror. Focal length is the distance of the what? Focus to the pole. Radius is the distance of what? Center of curvature. Thank you. All these are distance. And when we now say m represents what? Magnification. That magnification is the ratio of image distance to the object distance. Okay? Ratio of the image distance to the object distance is called magnification. Oh, okay. Are we good? Now, tell me, when you are dealing with positive, when you are dealing with real objects, will it be positive or negative? Yes. The distance of real objects, is it positive or negative? Positive. That's what the first column, first row is talking about. Read it again. What is there? Yes, real objects and real image are at positive distance from the mirror. Do you get that? So for real now, for real and for virtual, are we together? For real, U is what? U is positive. That's the meaning. And V is also what? Positive. Why? If the U is real and V is real, then they will be positive. Do you get that? But if it is virtual, what will it be? It will be negative. Our V also will be what? Why will it be negative? It is virtual. Which other thing did they mention? Number 2. We've done that. Yes, now focal length for concave. Focal length for concave is positive. Is positive. Why the focal length for convex? I'm not talking about real new Cartesian. For convex is what? Is negative. This is what we are going to be using in our calculation. I'm not talking about new Cartesian. I'm talking about real is positive alone. I'm trying to analyze it into 2. Convex. The last one, what's the last thing? Focal length of convex mirror is negative. Under real is positive. So now, equation of mirror. Very quick one. Equation of mirror. Equation of mirror. The general equation of mirror says that 1 all over F is equal to 1 over U plus 1 over V. This is the general equation of mirror. Are we good? The equation of mirror is what? Sorry. Is 1 over F equals 1 over U plus 1 over V. Now, if the question... Okay, before I go to that, we are going to answer past question now from this. Here, how can we get linear magnification? Said linear magnification is the ratio of the what? Image distance to the object distance, right? How can we get that here? If I multiply everything here by V, what will I get? If I multiply all by V, 1 over F times V is equal to 1 over U times V plus 1 over V times V. I will get V over F, isn't it? Equals to what? V over U plus V over V. V over V will give me what? 1. I have V over F to be equals to, what is V over U? Linear multiplication M. M plus what? Plus 1. So if I want to make M the sort of formula, I can bring this, right? And we have M to be equals to V over F minus, this is another formula for linear multiplication, aside from using this one. Good. Now let's try past question on this. Past question. On both concave mirror and convex mirror, begin to search for past question on them. Let's try. Let's begin to check. Any question? Tell me the year and the question, and we'll go through it together. 1995 question what? 1995 question. Question 34 and 35. Can we go there now, please? Let's go there and see. Everybody open to 1995 question 34 and 35. What do we have there? Are you there? Yeah, what do we have there?
If you're doing graph and saying the relationship between M and U.
For a converging mirror. What's a converging mirror? That we have not talked about that too. What's a converging mirror? Converging mirror. Converging mirror and diverging mirror. Converging mirror and diverging mirror.
Converging mirror is concave.
I want to check something. 1995. Question 34. No, don't check. Oh yeah, ready, let me know. I'm coming, I'll check something. Converging mirror and diverging mirror. How do we get the name converging and diverging? It's from the ray of light. So look up. If we have beam of light towards a concave mirror, this is a concave mirror. when ray of light, beam of light rather, when they strike this ray, this one will reflect light in this direction, like this, like this. This one will reflect the light back in this direction. The lights are coming to one direction, yes or no? They are what there? Converging. Okay, but if it is like this and the ray of light come to it, how will the ray of light go? Do you understand? The ray of light will what? Will scatter. That's what? The diverging. That is how we get where the name come from. Converging and diverging mirror. Now, yeah, back to the question.
Which of the graph below represents the relationship between M and B
For the converging mirror, let me draw the diagram. First one, second one, don't worry. The first graph is like this. Abi? We have M and we have what? V. The second one is like this. We have M and we have V. A, B. How does the third one look like? Other side. The third one is like this. We have M and we have V. The fourth one now. From down. Like this. We have V. Now, for a converging lens, this is a converging lens, which is what? Concave mirror. In a concave mirror, we want to compare M. M stands for what? Magnification. And V stands for what? Image distance. Image distance. Now, what can you tell me about the magnification? The image distance, does it determine the magnification? Yes. When the image distance is greater, what happens to the magnification of it? For example, let's take it like this. When the object is beyond C, the image will be formed where? Between C and F. Abi? When the image is formed between C and F, what can you tell me? The distance of that image and the mirror, it will get closer, yes or no? Remember, we have it like this. Go back to that note, you see it. When the image is here, the image form around here, Abi, like this. The image gets closer here. This is our V. Are you getting what I'm saying? What can you tell me about the magnification? Does it increase or reduce? It reduces. So definitely, the more the distance, the greater the what? The magnification. The lesser the distance, the lesser the magnification. You know what I'm saying? The more the distance, the more the magnification. Which distance? Image distance. From the formula to V over U. When this one increase, what will happen to V? It will increase. Directly proportional, right? Yes. Between this and this, they are directly proportional. So definitely, which one does it follow? A. What is this one saying? This one is saying that it's inversely proportional, Abi. When this one is more, this one is small. It's reducing like this. This one is inverse. Why this one is starting from a particular number? No. This one starting from a negative? No. D. Oh, we have negative value, positive and negative. Positive and negative magnification. Can we have negative value for magnification? Yes. When will our magnification be negative? When this one is what? No. When we have this one to be virtual. When we have this one to be what? I said it here that virtual image is what? Is negative. Sorry. It's not starting. This one says that it's starting from the origin. It's not starting from the origin. It's this. It can start from negative value upward. If it is here, this one says that it must start from the origin. No. This. Yeah, let's check the second one. Question 35.
A real object is placed at distance. Look
at that question. Can I play? Question 35. 1995. Yes. A real object is placed. Where would the object be? Which type of mirror? Concave. Okay. So when you have the object, real object in concave, is it going to be positive or negative? They did not tell us the mirror. Curved mirror. Okay, continue. U object distance. I can't hear you, please. Focal length. Now look at that statement too. If the image is upright and magnified, can that be convex? Can never be convex. Why? Convex will never produce what? A magnified image. Yes or no? It will never magnify image. At any position in front of a convex mirror, the image will always be what? Diminished. So that mirror is a what? Concave mirror. Are we together? So now, it's just for you to check the property and pick your answer. Now, we have object distance, focal length, and we are told that the object is what? The image. The image is upright. Our V is upright too at the end. Upright image. And what happened again? Are magnified. Our M is positive. Okay, that's what the option is. First option tells us that the mirror is convex and U is what? Is that correct? No, it cannot be convex. Second one. Concave and U is equal to 2F. Let's check that. When are you going to have look up? This is our center of curvature. This is the focus. When will the image be upright? That is when the object is between what? When the object is here. That is the only time the image will be what? Upright. Isn't it? So now, this is the distance that is called what? This is the object, Abi. This is the distance that is called U. Isn't it? Yes. Why? This is the distance that is called what? V. Don't forget, V in this place will be what? Positive or negative? Negative. And what can you tell me about the focal length? F is equal to, what does that statement say? F is equal to 2U, Abi. Okay. Go to the next option. Go to the next option. Options. It cannot be convex. That one is out. U is equal to 2F. Option B, check the option B. Option B, I'm asking now. U is equal to 2F. Is that possible? What is F? F is the distance from here to here. Abi, can this distance be twice of this one? Are you getting what I'm saying? This U here, can it be twice of this? It's not possible. Because U must be less than what? F. When it is at F, the image will become at infinity. For the image to be upright, that means the object is between between F and P. That distance cannot be up to F again, so it cannot be twice of it. Option B is also wrong. Option D. What's option D? Option D is what? Option D. U is equal to F over 2. This one can be possible. It can be half of F. Look at it now. U can be half of F and it is what? Concave. Option D is correct. Not convex, so concave. Don't pick any convex. Convex cannot produce image that is magnified. That one is odd. So now check the concave. The first concave told us that the object distance, please listen to the first one, you know, there is no number there. We are just trying to analyze it. The first one told us that the object distance is twice of the focal length. U is equal to 2f. Can that be possible? If the object distance is twice of 2f, when the object distance is twice of 2f, where is the object? At C. Thank you. That means the object is here. Because I told you that radius is twice of 2f, is it? And if the object is here, can the image be magnified? You are not getting what I'm saying. If the object is at C, R is the radius. Radius is the distance from where? From the pole to the center. Abi? That is radius. Radius is twice of the focal length. So if you are telling me that the object is at U, and that U is equal to 2f, that means the object is here. If the object is now there, the image form cannot be magnified. Tell me the properties of object, properties of image form at this position. Tell me. It will be inverted. One, the magnification will be one, the same size, and it will be what? It will be what? Real. It doesn't even follow this option at all. Option told us that question tells us that it will be upright. One, it will be what? Magnified. Two, and it will be, I think that's the two things. Upright and magnified. And if it is here, it cannot be upright. It cannot be magnified. Then D is the correct answer. Do you get that? Yeah, let's check another one again. Question 2, 1997. Question 34. Is it 34 or 35? 30? 34. 4. Yeah, check 1997, question 34. After your question, I will now ask you my own question. Who is reading for us? Somebody should read, please. Can you read for me?
The boy looking into a mirror observed that his face appeared to have grown bigger.
Look at that too. Wait. The person observed that the face looks bigger. Looking bigger means what? Magnified. What can that be? Can it be plain mirror? Can it be convex mirror? Then it has to be what? Concave mirror. Abi? Yes, continue reading.
The boy must have been looking at a convex mirror with his face at the focus.
Wait, look at that first option. Concave mirror, Abi? Convex mirror. Can it be convex mirror? That one is even out of it. Yes, second option.
Concave mirror with his face between the focus and the focus.
Look at that. Concave mirror with his face between the what? Focus and the mirror. Can that be? Between the focus and the mirror, that is between F and P now. That's possible. Is it not possible? When it is there, it will be magnified and the image will be upright, isn't it? We are read option C. Option B is correct too. Let's read C. Can it be? If the face is at the focus, where will the image be formed? Infinity. Option C is out. Option D, it cannot even be convex mirror. So option B is correct. This is very simple now. Very simple. So this one is option B. Yeah, number 3. 1998 question. 29, 30. This is much. Yeah, let's go into it. Question 29. Let's see what is there. Question 29. What do we have there? I can't hear you. That is the object distance now. Object distance is m, small letter m, right? Okay. Which type of mirror? Concave mirror. And the focal length is what? Focal length is what? F. F. Okay. If m, this focal length. If m is lesser than f, now tell me, class, we are looking at concave mirror now. Decorum. Concave mirror. M is standing for the object distance. When the object distance is lesser than the focal length, where are we talking about? We are talking about this place. Object distance is lesser than the focal length. Are we together? So the image will surely be what? Before you check the option, tell me what the image will be like. Upright, magnified, erect, virtual, not inverted though. It cannot be inverted now. And virtual, right? And it is behind the mirror. Yeah, let's check the option. Option A. Can it be diminished? It cannot be diminished. Option A is out. Option B? Magnified and erect. Yes, it's possible. Option C? Real is not even real. And it's not even inverted. That one is out. It cannot diminish, but it can be erect. But the correct answer is option what? Option B. Do you get that? Or do I need to, should I draw the diagram or you get it like that? The diagram is that of I think second to the last that I gave you. Go back to the diagram I gave you before. I said this is the mirror. This is the center of curvature, for example. Here is the focus. Okay? When the object is here, when the object is here, this is the object. That means that the object distance. See, this is where you calculate the distance. You are calculating the distance from the mirror. So from here is the distance. From here to here, the distance is m. From here again to here, the distance is f. Which one is longer here now? F. So they said m is lesser than f. It's obvious here. So definitely that object is between what? P and F. If the object is not here, according to what we've done earlier, you will see that the image will be what? Magnified here. I mean, it will be upright. What do you say? Yes. They have been repeating this question, but in different ways. Different ways. So did you get that now? That's the reason why we pick this answer. The image is upright, the image is magnified, and the image is virtual. Did you get that? Yeah, let's leave that one. Question, what's next now? Question 30. Question 30.
Kind of fish. Let me look at different industries. Give me better. Give me. Like just looking at it that. Give me. Let me know.
Yes. Question what now? Question 30.
An object is placed in front of two plane mirror, inclined and
Look at this now. We did not talk about this one earlier. It escaped my mind. When you place two plane mirror beside each other, the device form is called a kaleidoscope. It's called what? Kaleidoscope. When you place two mirror, what do you say? I should spell it. Kaleidoscope. Kaleidoscope is made up of two plane mirror. When you have a plane mirror like this, you have one like this, you have another one like this. Beside each other at an angle. This is mirror 1. Are we together? And this is mirror what? Mirror 2. Two plane mirror. When you place them beside each other, they are in contact here, and the angle between them is theta. This device is called a what? A kaleidoscope. Yes, a kaleidoscope. How do you now calculate the numbers of image form? Let me just quickly tell you the formula. The formula to calculate the numbers of image form is 360 divided by n minus 1. Divided by theta minus 1. This will tell us the numbers of image form. Do you get that? Numbers of what? Image form. 360 over theta minus 1. This is the formula to use for a kaleidoscope. Oh yeah, let's answer that question now. Let's answer the question quickly. What do you say? N stands for numbers of images. Numbers of image formed. While theta stands for angle of contact. And 1 is a number, you know that one. 360 is an angle, you know that one too. Well, let's answer question 30 now. Back to class, everybody. Question 30. Yeah, tell me now.
An object is placed in front of a plane mirror, inclined to an angle of theta.
They said it's placed in front of two plane mirror, inclined at an angle of theta. Let's assume this is the diagram. Yes, continue.
If the total number of image form is 7.
Now they said if the total numbers of image formed is 7, total numbers of image form is 7. That means n is 7. Abi, 7 is equal to 6 all over theta minus 1. Move this one. 7 plus 1 is equal to 360 over what? Theta. 7 plus 1 is what? If you cross multiply, theta is equal to 360 over what? Theta is equal to, let's divide. 8 here, 1. 18, no, 8 cannot go in 36 now. Let's use 4. 4 here, 2. 4 in 36, 9. 90 divided by 2 is what? 45 now. Our angle is going to be 45 degrees. They are inclined at 45 degrees. I have a question for you. Class, I have a question for you. When you have two plane mirror inclined at an angle of 90, how many images will be formed? Two plane mirror inclined at an angle of 90, how many images will be formed? Somebody said 2, somebody said 3, another person said 4. 14. 360 divided by 90 is 4. 4 minus 1 is 3. 3 images will be formed. Now, look at it. Stay decorum now. We have one plane mirror like this. Are we together? If you stand in front of this plane mirror like this, your image will be formed here. Yes or no? One image will be formed, isn't it? If you have another one here, this image will be formed here again, isn't it? Let's now assume the angle between them is 90. Another image will be formed here. at their point of contact, another image will be formed here, making how many images? 3. One here, and one here. But when they get closer, if they get closer, you observe that, are we together? If they get closer, you observe that the image from here, let's say this is the object, the image of this object that is formed here, this one will see the image again. It will become an object for this one, then the image will be formed here again. This one will see it again, you will have many images forming, and the last one will be formed at the middle. So this angle at the middle determine the numbers of images that will be formed. If they are wider from each other, they will not easily see the image of this one to form another image in that one. You observe that before, I don't know whether they still do it, they don't do like that again. When I was small, if we go to the barbing salon, then the mirror are always being positioned like this. When they are cutting the back side of your hair, you will be seeing it, Abby. And if you observe it very well, you will see yourself like this. It will now go, it will go far. You will be seeing, you will see this one, see that one. It will continue going. Why? Because of the angle. The way they position it. If you draw the parallel line like that, their line of symmetry like that, the line will later meet at an angle. The angle at which they meet will determine the numbers of images that will be forming them. Do you understand? That is one of the advantages of using this device, kaleidoscope. If they are parallel, then the image will continue. The image will just continue. But you may not directly see the back. You may not directly see the back of that person. Let's check question. What's the next question?
31.
Let's check question 31.
The most suitable type of mirror used for the construction of a searchlight is that.
Searchlight. Spread the search.
S-E-A-R-C.
Let me see this. The searchlight. The most suitable type of mirror used for the construction of a searchlight. Yes, what mirror would that be? That can go far very well. What type of mirror would that be? Oh yeah, option A. Concave mirror. Option B. Option C. Spherical mirror. And option D. What do you call it? Parabolic mirror. Not like parabolic mirror. They are still talking about curved mirror. Okay? They are still talking about curved mirror. Look at it. Concave mirror. Convex mirror. Spherical mirror. All the body is mirror, but the inside part is the silver coated. All the body is mirror. Which one is best used for a searchlight? For a searchlight, you want to search. What do you say? Who can tell us now? Which one is best used as a searchlight? As a searchlight. Which one is a parabolic mirror? Parabolic is talking about what? Curve. Yes. Abi? Yes. So, a curved mirror. We call it. Parabolic mirror. As a searchlight. How does a searchlight look like? Who have seen a searchlight before? Searchlight. Look at it, class. Yes, like this. So generally they are just curved mirror now. Both of them are curved. Generally curved. They are used as, but this one used to diverge light now. No, this one converge. This one converge. Why this one diverge? But this word capture the two. When you say parabolic, you are saying curve. It capture the two. Let's go for this. Curve mirror in general. Curve mirror. Oh yeah, check for another one. Check for another one. Number 33. Yes, curve mirror, parabolic. Question 33. Oh, curve mirror in general. Question 33. What is it? That's curve now. Parabolic means curve. Number 33. Of a glass. Graph. Okay.
Of UV against U plus V for an object distance U and image distance V. In an experiment to find the focal length of the convex lens is given as
convex lens. We have not gotten to lens, so that one is different. So. Convex lens is different. When to lens, we answer that one. Oh yeah, go to another one. After this mirror now, we are going to lens. When we get to lens, I'll study the question. We answer it. This is the last question I will answer. I will now start giving you question. 1999. Question what? 25. For now, we are answering question on mirror. When we see question on lens, we push it to when we get to lens. After this mirror, we are going to lens, okay? And 26. So yeah, let's check. Check it. 1995 question 25.
a man stands 4 meters in front of the mirror.
Is a mirror, Abi? Man stand what distance? 4 meters in front of what? Let's assume this is the mirror. The distance between me and the man standing in front of the mirror, what's our distance? 4 meters. Yes, continue.
If the mirror is moved 1 meter towards the man.
If you now move the mirror 1 meter towards the man, definitely the distance, my distance and the mirror will change to what? 3. Okay.
The distance between him and the new image is.
The distance between the man and the new image will be what? Will be 6 now. Will be twice of the distance, because that man and the object is 3. The object, the mirror and the, what am I saying? The man is the object. The object and the mirror, the distance is what? 3. Definitely the image and the mirror too, the distance will be what? 3. They're not together, will be 6. That did not even involve any calculation. She just give us 6. 6. Now let me ask my own question. Abi? 1. Yeah, 26.
The inside portion of the car of the odometer of diameter 20 cm is polished.
Look at that too. The inner part is polished. If the inner part is polished, what type of mirror will that be? Convex. It should be convex, Abi. Look at the scope. Continue.
The concave mirror of focal length 5 cm.
Wait, what is the diameter?
20 cm.
Diameter is 20. If the diameter is 20, radius will be what? 10. Their focal length will be what?
5.
Are you with me? And it will be a what? Convex mirror.
The concave mirror of focal
A first. Option A.
mirror of focal length 5 centimeters.
Convex mirror with focal length. Concave. Is it a concave mirror? Concave mirror is out of it. Option B.
Concave mirror of focal length 10 centimeters.
Out of it. Option C.
Convex mirror of focal length 5 centimeters.
Is that correct?
Yes.
That's correct. Option D.
Convex mirror of focal length 20 centimeters.
This is the correct answer. Because diameter, half of diameter is radius, and half of radius is the focal length. So you divide it by 4. You get 5. Now I want to ask my own question. Let me check this textbook for question. Adjust. Now, answer this my question. Right, everybody. My question now, right. An object is placed 2 meters in front of a convex mirror. An object is placed 2 meters in front of a convex mirror such that the magnification of the image is 1/3. Yes. Let me read again. An object is placed 2 meters in front of a convex mirror. Are we there? Such that the magnification of the image is 1/3. Calculate the focal length of the mirror. Calculate the focal length of the mirror. You have 1 minute to answer the question. No, I said 1/3 magnification. 1/3 magnification. Yes, convex mirror. Time up. What's the answer? Your answer is what? 3. What are you asked to find? Somebody said the focal length to be what? 3. Let's write the question first. Let me quickly write the question. Read the question for me. Of the what?
Convex mirror. Such that an application of the image is 1/3.
Calculate what?
Calculate the focal
Down. Yeah, somebody said the answer is 3. One person is saying -1. Oh. Another person. Oh. I'm waiting. After the count of 10, you all stop. After the count of 4, you all stop. 1, 2, 5, 6, 8, 9, 10. Stop everybody. Stop everybody. Alpha, what's the answer? 4/3. That's good. Alaja, what's the answer? You, what's the answer? Your answer? 1 over 6. 6. 6. Some people get, somebody got 3. Another person got -1. Somebody said 4 over 3. Another person is saying 6 now. 1 over 2. We have 1 over 2. We have 5. You have 2. Thank you. Somebody have 2. Yes. 3. 3. 1.6. Yeah. 1.6. Yeah. 1.6. 3 and 1.6. Now let's check for the correct one. Please know yourself. Oh. We have 3 times. Tautology. Repetition. Know yourself. Oh. Those of you that you pick 3, know yourself. -1. Know yourself. 3 and 6. Solution. I'm shouting. Oh. Decorum now. Can I continue? Okay. Now, the first condition that will determine your formula is which type of mirror. The type of mirror will determine your formula. What's the answer? No money for you. The mirror is a convex mirror. And for a convex mirror, we know that what? An object is placed. Object distance is always what? Positive. U is positive. Yes or no? Image formed in a convex mirror, is it real or virtual? The virtual images are what? Negative. V are negative. What of the focal length? The focal length, is it positive or negative?
Of a convex mirror.
Thank you. The focal length is what? Negative. For a convex mirror. Are we together? Now let's apply our formula. What's the general equation? 1 over F is equal to 1 over U plus 1 over V. But because of this condition, formula change to what? -1 over F. Why? For a convex mirror. For convex, focal length is negative.
Yes, sir.
And for a virtual image, the image will be what? Negative 2. 1 over U minus 1 over V. This is our formula. Substitute now. What is the focal length? We don't know.
Size 1. So
What of U? U 2. What of V? They not tell us V, Abi. Okay, they gave us magnification. Okay, and object distance. What formula should we use to get? What is magnification? N is equal to V over U, Abi. Magnification is given to be what? 1 over 3. 1 over 3 is equal to V all over 2. Abi, if you cross multiply, you have what? 2 over 3. V is 2 over 3. Will it be positive or negative? Negative. Why is it negative? Because V will be negative. Let me put the minus from here so that I will not be confused. Back to the formula now. 1 over F equals to 1 over U plus 1 over V. We are changing this and we are changing this to negative. Minus 1 over F is what? F is what we are looking for. 1 over U. V. We cannot use minus again though, if you are using minus. Once you use minus, you cannot use minus again. I will just use that 2/3 direct. Okay? This will become what? Minus 1/f equals to 1/2 minus 3/2. Did you get that? LCM 2 2 1 1 minus 3 1 minus 3 minus 2/2 is equal to this. Minus 1/f is equal to minus 2/2 is what? Minus 1. Cross multiply. Minus f. We cannot get positive for f. That is, we are repeating. Let's do like this. Let's do like this. Let's remove minus from our formula. And we substitute minus in the value. So we have minus 1. F will be equal to minus 1. Please, don't get me wrong. Go. See, this is the general formula. Okay? This is the general formula. We know that for a convex mirror, F must be negative. That's the rule. And virtual image are also negative. So anywhere you want to substitute for V, you must use negative value to substitute for it. That's the reason why I'm using this formula back. But when I'm substituting for V, I use negative. And by the time I get my value of F2, it will take what? Negative, direct. So it will be easy like this. This is the person that is correct, and that's this guy. So you're just forging. What is the time? Is this correct? Is this correct? 1:33. We have 1 hour. 1 hour more. Okay. You can proceed then. My last question for you today. Try this question. The last question for curved mirror. Try this question. An object of height 2.5 centimeter. Height. Yes. An object of height 2.5 centimeter. Height. An object of height 2.5 centimeter is placed 20 centimeter from a convex mirror. Please, I can't shout. An object of, who can tell me, 2.5 centimeter is placed at a distance of 20 centimeter from a convex mirror. 20 centimeter from a convex mirror. Of focal length 10 centimeter. Focal length 10 centimeter. Full stop. Calculate the height of its image. Calculate the height of its image. Calculate the height of its image. I'm waiting for your answer. You are not working, but you are telling somebody what to do. You are explaining to somebody that has been here before you. That's funny. it true? What are you asked to find? Image height.
Can you make that
Let me see.
But in this one, we don't okay. If you use that, wait, that means going to be there.
Four. Definitely. You got what? You are correct. What's the answer? You can get the height from the magnification. Magnification is image distance all over object distance, abi? And it can also be image height over object height.
They give us object height and object distance. So you is the object height. Don't have distance.
I don't get what you're asking.
Right? They give us object height and you say object height is equal to object distance.
I did not say they are the same. I said magnification is the same as the ratio of, so M is equal to V over U or HI over H naught. HI means image height over object height. V over U is equal to HI over H naught, and they are both equal to magnification. The ratio of image distance to object distance is the same as the ratio of image height to object height. I'm not saying they are exactly the same thing, but their ratio is the same thing. Do you understand? Just like 2 over 10, for example. 2 over 10 is the same thing as what? 1 over 5 in ratio. But 2 is not the same thing as 1. 10 is not the same thing as 5. But if you find their ratio, it will be the same. Do you get to answer now?
So minus 1 over 10, but they gave us a positive to change it to minus. And the formula for convex is 1 over U minus 1 over V. So this is minus 1 over V. Then now change subject of formula 1 over V because bringing the first 1 over 20 minus
Plus.
minus 1 over 10.
That's plus.
1 over 2 plus 1 over 20 plus 1 over 10. LC, I'm coming. 20.
Can I do correction now? What is your own answer now? 0.3. That's wrong. What's the answer, sister? What's the answer? You're not right. You came late. And don't come late. Do you have answer now? This one you are smiling like rice. Do you have answer? 2 points. That's wrong. Wrong. 1.25. You are wrong. So let's do the fraction of light. Let's be fast. 0.825. That's correct. Correction, everybody. What's our general formula for mirror? 1 over F equals 1 over U plus 1 over V. Right? Are we together? Okay. But for a curve, it's a little bit different too. We know that the focal length will be what? Negative. And it will produce a virtual image. Virtual image are always what? Negative. So we have this. Check the givens. So yeah, tell me the givens in the question. Object height. We are given object height 2.5 centimeter. We have to find image height, right? What other thing? We are given the focal length to be what? 10 centimeter. Which other thing again? Distance of the mirror, that is U. 20 centimeter. These are the givens, Abby?
Yes, sir.
So let's apply it into the formula. Something is certain. What is that? Magnification is V over U. And it is equal to what? HI all over what? HO. The ratio of the image distance to the object distance is called magnification. Also, the ratio of the image height to the object height is also magnification. Do you get that? If I apply that, I have, yeah, what would that be? My formula first. 1 over V, I want to move this like this. 1 over V is equal to 1 over U plus 1 over F. So I have 1 all over V is what? We are not given V equals to 1 over U 20 plus 1 over F 1 over 10. Are we together? This tells us LCM is 20. 1 plus 2. That gives us 3 all over 20. So definitely what is V? 20 over 3. In decimal, that will give us what? 6.67. Let's leave it at that. What is magnification, class? This is it here. Abi? Magnification is V over U, which is equal to what? HI over H naught. Abi? What is our V now? 6.67 over U. Again? 20 equals to HI. We don't know. H naught 2.5. By the time we cross multiply, we have 6.67 times 2.5 divided by 20 to be equals to HI. Image height. Image height is equals to what? What's the numerator? Or just find the total answer, multiply for me. Approximately, right? This is the answer. Do you get that now? So, okay, ask your question. Concave. Is having minus now? See it here. See it. I gave you what here? Minus. So that's why I move it to this side. Then I move this one to this side. It's still minus. Do you get that? It's still minus. It's just like you have x minus y is equal to 7. What's the value of y in this place? It's negative, Abi. But if I write this equation, I can write it as s is equal to y plus. That does not tell us that the value of y is positive. No, it's still negative. It's because I changed the position. Do you get? It's still negative. It's the same thing. Okay, now let's move to refraction of light. Refraction of light. Please let me know once it's almost time, so that I can know how to round up. That will be 2:30 now. We did not start one. We did not start by 10. By 10, I think around 10:30. So how many minutes do we have left? I calm down now. Now it's like 42 minutes. For 2:30. 2:30. Let me ask. I should not ask. That means you are not saying the truth. Refraction of light. Now, when the refraction of light happen, when will it happen? When the light ray, okay, when the ray of light passes through a medium. When a ray of light passes through a what? A medium is called refraction. Refraction of light occur when a ray of light passes through let me use this word, passes through two media of different densities. Passes through media of different density. Refraction of light occur when ray of light passes through two or more media of different densities. Did you get that? And when it passes through it, in most cases, the light ray will bend. What will make it bend? Because of the density. Once it passes through different density, the light ray is going to do what? It's going to bend. We are going to look at how it bends now and what makes them to bend. We are going to look at that. Now let's check. This is the normal ray, right? Normal ray is always perpendicular to the what? To the surface. This is the boundary. Boundary between two media. Let's say this is air and let's say this is glass. Okay? Light ray want to move from air to glass. One is certain that will go straight. That is the normal ray. If you have an incident ray like this, This is the angle theta I. What will happen? It's going to come down instead of it to go straight. You know, normally it's supposed to keep going like this, but instead of it to keep going like this, it's going to bend. Going to bend towards the what? The normal. It will come down like this. Then this is our angle of what? Refraction. Why? Angle of incidence, angle of reflection, and angle of refraction, they are always calculated towards the what? Normal. They are always calculated towards the what? Normal. Angle of incidence, angle of refraction, angle of reflection, you must calculate them towards the normal. You observe that when I drill angle of normal, then the normally the angle of incidence then for reflection, angle of reflection, where did I put it? I put it here. It must always be towards the what? Normal. This one too must always be towards the normal. So we have this. Let me give you a short note. Let me give you a short note. After drawing that diagram.
That's what they say. Short note.
It's just short now. Now, keep
Sorry, we are back. Yes, sir.
Okay, can we continue now? Hello, can we continue? Okay. I talk about refractive index. Refractive index. I said it is a constant for a given pair of what? For a given pair of media. That law is not my law. It is the law by Snell. It is also called the Snell's law. Snell's law. It tells us that the sine of angle of incidence compared to the sine angle of refraction is a constant for a given pair of media. That's the Snell's law. So if it is now moving from air to glass, we consider it like this: air to glass. So that means the incidence will be in air and it will refract into the what? The glass. And if it is glass to air, or if it is water to if it is water to glass, what will it be? Water to glass. I in water all over R in glass. Do you get that? As simple as that. Let's try some questions.
Speed of light.
Yes. It is depending on where the ray of light is coming from. That is how you can trace it. They will tell you where the ray of light is coming from. You will trace where the ray of light is coming from. And don't forget that it is reversible. See, if it is coming from this to this, it is the same thing as 1 all over coming from this one to this one. So you just trace it. If you are tracing from here, you trace like this. And if you are coming back, you go in the other way around. To still give you the same answer. Let's try. Oh yeah, open your past question. Before we go into the question, write this down. General relationship between n and sin I. General relationship between n and I. Let's be fast now. General relationship. See. General relationship between n and sin I. N sin I is equal to constant. Between n and sin I. N sin I is equal to constant. That means n in glass, sine in glass is equal to n in air, sine in air equals to water. No matter amount of medium you are having, this value will always be a what? Constant. Keep note of that. It will be useful for us as we go. What did I use? No, this one is W. Let's try this question. Example 1. A ray of light passes through glass of refractive index 1.5. A ray of light passes through glass of refractive index 1.5. A ray of light passes through glass of refractive index 1.5. Are we there? Full stop. If the speed of light, a ray of light passes through a glass of refractive index 1.5. If the speed of light in vacuum is 3 times 10 raised to power 8 meter per second. 3 times 10 raised to power 8 meter per second. That is the speed of light. I think we've discussed that before. Speed of light in vacuum now, you know now. Speed of light in vacuum. Determine the speed of light in the glass. 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 So what do we have there? We can use this formula. Yes or no? What does the formula say? The refractive index of glass relative to air, Abi, is equal to what? The speed of light in air all over the speed of light in glass. Did you get that? Solution. We have speed of light in air all over speed of light in glass. Refractive index of that glass relative to what now? Air. That means the ray of light is coming from where? From where? From air entering the glass. Read the question now. What does the question say? Yes, it's coming from air. It will pass through where? Pass through the glass. It will be refracted from the glass. What is the angle of the refractive index? 1.5 is equal to speed of light all over the speed of glass. So the speed of glass will be equal to the speed in glass rather. What will be our answer? 1.5 in 3. So that will be what? 2 times 10 raised by 8 meter per seconds. I need another ink.
You already know what consumption is. You already know what consumption is, right? Now, the consumption function, we look at the differential consumption function. C equals A plus BY. A is autonomous consumption, C is consumption, A is autonomous consumption, BY is what? BY is disposable income. I don't know what disposable income is, right? Right? What is A? Autonomous consumption. What is BY? Disposable income. I will explain what autonomous consumption is. Whenever you hear autonomous consumption, I'll go back to the right. Whenever we talk about autonomous consumption, we are simply talking about a consumption that occurs as a result of.
Please, do you understand that question? That one is clear. Now let's consider 3 material medium now. 3 at a time. Look at this question. A ray of light, example 2. A ray of light passes from air to water to glass to air. A ray of light passes from air to water to glass to air. A ray of light passes from air to water to glass to air. Are we there? Full stop. Given that the refractive index of light passing from air to water is 4/3. Given that the refractive index for light passing from air to water is 4/3 and air to glass is 3/2. Given that the refractive index of light passing from air to water is 4/3 and air to glass is 3/2. And air to glass is what? 3/2. Are we together? So what do you want to get now? Calculate the refractive index of glass relative to water. Calculate the refractive index of glass relative to what now? Water. This one on the board is what? What's this? Refractive index of what? Glass relative to air. This one is what? Do you get that? What you are looking for, the question says, I can't shout again. Calculate the refractive index of glass relative to water. That's the question. Glass relative to water. Can we go ahead? Are we ready? You are not answering now. Do you want to solve it? Let's do it together. Yes? Question. Let's try to draw it. Let's say this is air. Are we together? This is water. And under the water again, we have what? Glass. You know, this is possible now. Let's say you even have glass cup. If you have glass cup and you want touch light from the up, the light will move from air into the water. Abi? If the glass is transparent enough, the light will also come out from the glass to the table. Isn't it? Is it not possible? It's possible. That means the light is traveling from what? Air to, and from water to, and back again to what? Yeah. It's possible, right? Let me use this side. If the ray of light, this is the normal. If the ray of light coming like this, will it go away from the normal or it will come closer to the normal? Coming from air to water, which one is denser? Which one is denser? Water. Will it move away from the normal or it will move closer to the normal? Closer to the normal, like this. Striking this place now. Between water and glass, which one is denser? Glass. You can see that the particles of glass are tightly packed. The density is higher than that of what? Water. Water is still a little bit loose. This one will not even move more closer like this. It's not a straight line, no. On striking this place now. How will the light emerge from here? Should the normal or away? Like this, to go out like this. This is the incident ray. This is refracted ray from the air to water. This refracted ray now become another incident ray for the glass, Abi, which will refract like this. And this refracted ray again now become incident for this one to emerge. Are we together? So now, we are given something. I read the question. What are the givens? Air to water. 4/3. Stop the noise now. Air to glass. 3/2. We have to find what? Glass relative to which one will come first? Glass will come first. Water will come first. Glass relative to water. Water relative to air. Glass relative to air. Do you get? This is what we are looking for. If we take it as a ratio, this is air to water. and this is what? Air to glass. I want to get what? Water to glass for my ratio. This is just a ratio value. I will have A all over W. If I divide by this, divided by A over G, what will it give me? What would this one give me? A all over W times G all over A. This cancel this. Abi, what did I have? G over W. That means I'm having what? Glass relative to water. Abi, if I find the inverse of this one, it will give me what? Water relative to glass. Yeah, let's go ahead. What will this give me? This is what I'm doing now. Glass relative to water is what? A over W times G over A. So what would that be? Glass relative to water will be A to water is what? 4 over 3 times glass to water. Glass to air to glass is 3 over 2. Then glass to air will now be what? 2 over 3. This multiplied by this give me what? 8, and this give me what? 9. So tell me, what will now be water relative to glass? 9 over 8. In decimal is what? 1 point what? 1.125. 1.125. 3 29. Okay, 229. It's time now. Okay, let's do one question from the past question, then we stop. I know. Oh yeah, check for one question from the past question. After this rectangular glass prism now, the next one you should be looking at should be triangular prism. That is very, very simple. Very simple. It's even simpler than this. You want them to be afraid of it. Oh yeah, check the past question. Let's do one question, then we call it a day. 1993. Question 29. Oh yeah, put it. Let's see what is there. 1993. Question 29. Are you there? 1993. Regular prism is simpler. I said it. Continue now.
A beam of light is incident from air to water at an angle of 30 degrees. Find the angle of refraction.
Let's read that question, everybody. Look at that question. A beam of light is where? Incident from air to water. That would be ANW. Are we together? Air to water. Continue. The angle of incidence now is 30 degrees. Angle of incidence is 30 degrees. What are we have to find? Let me use I. I is 30. R is what we are looking for. What's the refractive index? 4 all over 3 from water. Class, what is the formula? Using the Snell's law. Snell's law says that what? The sign of I in what now? In air. All over what? In what? In water. Do you get that? This is 4 over 3 equals to sine of 30 now. Sine 30 all over sine r. Are we together? So this will give us cross multiply. You have sine r is equals to 3 sine r. R sine inverse of 1.5 divided by 4. 0.375. R is equals to what? 30, 22. So we are coming to the end of the class now. We are about to come to the end of the class. So ask any question on what we have done so far. Ask your question on what we have done so far. Your question should not be calculation anymore because we've been doing calculation. You can ask question on what you don't understand. From a less dense to a denser, okay? It will reduce. Oh. Yes, it will reduce. The rate at which it will travel will reduce. Even the speed, not only the wavelength, the speed will reduce. Yes, the speed of light in air. That is why speed of light is fastest in air. Once it passes through a material medium, it will reduce. The maximum speed of light you can have in glass is 2.0. 2.0 times 10 raised to the power what I mean, raised to the power 8. While in glass, in air we have 3.0. In water is around 2.5. Thereabout maximum. It will, frequency. No, the frequency will become. The frequency can be the same, but the wavelength will reduce to become shorter. I cannot write S now. It's 5. Can we call the class a day? Okay. Which one? Yes, 22. 22 degree. 22 degree. Now, we come to the end of the class. I want to ask questions on everything we have been doing so far. Let me clean the board. You are not writing. Okay. Random question. Did I have money? Random question. Who can state the Snell's law? State it in full. Somebody is talking. You are not serious. Thank you. Is a constant for a given pair of media. The sine of I to the sine of R is a constant for a given pair of media. Who can state the law of reversibility of light? Law of reversibility of light. Say that what? Thank you. Say that light can be reversible between pair of media. Light can be reversible. The way the light pass through ear to ear to ear to ear, it can also go back like that, like that, like that, like that. Do you get that? That's what we mean. The law of reversibility of light says that light is reversible between a what? Given pair of media. Is reversible. It can go back. Another one again. Tell me one formula to calculate the refractive index of glass relative to air. Refractive index of glass relative to air. Sine I in what? All over what? Tell me the formula to calculate the refractive of water relative to glass. Sine I in okay over. Do you get that? Okay, good. Goodbye. Let's stop there.